Hi everyone. This video I want to go over sample exam number 3B, hypothesis testing the solution. So first let me show you this is the sample exam and the answers are right there anyway, but I've done the complete work for you guys, so you can go ahead and watch this and review for your exam. So let's go over the problems now one by one. The three first problems, these are just questions, conceptual questions, and I just brought the solution here for you, but let's go over them anyway. Number one, describe how to write a null and alternative hypothesis based on a claim. You may give an example to clarify your explanation. But this is what we did in class and in the last lectures. You have it, but let me read the solution. Write the claim symbolically, then write its complementary statement. The null hypothesis contains the statement of equality. Don't forget, it's always equal for null hypothesis. And the alternate or alternative hypothesis contains the other. So when we say the other, that means it could be not equal to, less than, or greater than. No equal sign for alternative hypothesis. Number two, explain how to determine the hypothesis test is one-tailed or two-tailed, and explain how you know where to shade the critical region. Give an example for each, which includes the claim, the hypothesis, and the diagram with the critical uh, region shaded. So, well, in this case, let you read the solution. However, when just to let you know, when you for that you take a look at sign of H1. If it's not equal to, then you know it's a two-tail test, and you shade the test. If it's greater than, then you know it's a right tail test, and you shade the right tail. And if it's less than, then you know it's a left tail test, so you shade the left side. Number three, list three phrases which are associated with one-tailed claims. So the possibilities are at least, at most, more than, greater than, or less than, or maybe no more than. So if you uh, read all that, so at least is greater than or equal to, at most is less than or equal to, more than is greater, and greater than is the same thing, less than is like that. If you hear no more than, that means less than or equal to. Number four, an entomologist writes an article in a scientific journal which claims that fewer than 10,000 male fireflies are unable to produce light due to genetic mutation. Use the parameter P, the true proportion, or we can say the population proportion of fireflies unable to produce light. First of all, 7 over 1000 is 0.007. So the claim says uh, proportion fewer than. That's another way of saying them is less than 0.007. This doesn't have an equal sign, so we know it's H1. So HO right away say P equals to 0.007. One more time, the final claim, when you look at HO, you have to see the equal sign. So C is the answer in this case. Assume that the data has a normal distribution and the number of observations is greater than 50. So these are just requirements which is given to you. Find the critical Z value used in the to test the null hypothesis. So it's a right tail test. So it does say right tail test. So we shade the right side, and that's alpha equals to 0.01. Do not divide alpha by 2 because it's only one tail. And the fastest way to do that, you can use your calculator. Do inverse norm 0.09. The mean is 0. The standard deviation is 1 because it's the standard normal, and you get negative 1.34. Be very careful. This is a right tail test, so change the negative to positive. So 1.34 is the critical value. D is the answer. So, and I put a right tail test. Therefore, this means therefore z equals to positive 1.34. Find the value of test statistics z using the formula. This is the formula for the test statistics when the claim is about population proportion. So, or one population proportion. Now let's see here. A claim is made that the proportion children who play sports is less than 0.5, and the sample statistics include n to be 1,671, with 30% saying that they play a sport. So the givens here are p hat, 30%, p is in the claim, which is 0.5, and q is always 1 minus p, which is also 0.5. So if you substitute zero point 0.3 minus 0.5 divided by square root of, this is the same p and times q, which is 0.5 divided by n was 1671. And if you do that, you get negative 16.35. Number 7, well, let's see what it says first. Identify the null hypothesis, alternative hypothesis, test statistics, p-value, and the conclusion about the null hypothesis and the final conclusion. Basically, this is a complete problem. So let's read it and go over the solution. A supplier of digital memory cards claims that no more than 1% of the cards are defective. In a random sample of 600 memory cards, it is found that 3% are defective, but the supplier claims that this is only a sample fluctuation. At the 0.01 level of significance, and this is alpha, test the supplier's claim that no more than 1% are defective. So here the givens are n, the sample has is 600, n is 600, the sample size. P hat is 3%, it's given here. This P will be in the claim and is 0.01. And right away, when you have p hat and x is not given, calculate x. We know p hat is x over n, so x will be n times p hat. So it's 600 times 0.03, 18. And you'll see when you use your calculator, you'll need that number. Write the claim. The supplier claims that no more than 1% are defective. So you write that first. P is less than or equal to 0.01. We see the equal sign. The claim contains the equal sign, so that's HO. H1 is the complement, so you write P is greater than 0.01. We wrote that claim first, and that claim is in the problem, so that's the original claim. And of course, H1 here will be the counterclaim. So final answer, always change this sign to equal. So HOP equals to 0.01, nothing else changes. So that's the original claim. H1P is greater than 0.01. So that's the counterclaim. Now let's look at those. We check that sign is greater than, so we know it's a right tail test. We set the right side, and sigma, or the significance level, is 0.01. This area is 0.01. To find the critical value, when the claim is about population proportion, we always use Z. So you can do inverse norm 0.01. Don't divide that by 2 because it's one tail, 0, 1, and you get negative 2.33. Since it's a right tail test, we take the positive one. The test statistics, you have all these formulas. It's given to you already. You don't have to memorize them. But it's p hat minus p over square root of p times q over n. So it's 0.03 minus 0.01 divided by 0.01 times 1 minus 0.01 divided by 600. And if you use your calculators, you get 4.93. Let's check where is 4.93 is after 2.33. So 4.93 is right here, and we see it's in the shaded area. And I wrote it for you. We said if the test statistics is in the shaded area, then the first conclusion, you say reject HO. Reject HO, go back to your claims, and you reject HO, just write reject. H1, if we reject HO, that means we accept H1. Then take a look at OC. Where is OC? Next to reject. We are rejecting the original claim in this problem. So the final conclusion is going to say not enough evidence to support the original claim because we rejected it, or the claim that basically the supplier's claim that says P is no more than 0.01 or 1%. Now, if you want to use your calculator, you can go to stat test and pick number 5, and which is one prop z test, and you can just put the givens. Let me see if I can share my screen. Let me stop sharing this and share the calculator screen, and I want to show you how you can do this with your calculator. All right, so one more time, you go to stat and you go to test and you go to number 5, one prop z test. This is not z interval, so it's z test. Enter that and you can put the givens. P0 is the claim in, is the proportion in the claim, guys. That was 1%, no more than 1%, is 0.01. X we calculated, that's why I say calculate X. It's 18, it's P hat times N, and N was 600. And here for the claim, or at the end for the tell, you just pick whatever you see for H1. H1 said P is greater than 0.01. That means the proportion is greater than 0.01, so it was a right tail test. So whatever you have in H1, pick that one. And then you just go to calculate. And let's enter that. Let's see what we get. So we have the claim here. Z is 4.92. We calculated that. The calculator gives you that value. That P here is P value, which is called the probability value. That's another way to make the conclusion. So we're gonna, I'll show you. So remember, P is 4.25 times 10 to the power of negative 10. That's a very, very small number. Do not just put 4.25. Don't forget, when you see this e to the power of negative 7, that means 10 to the power of negative 7. Basically, we're going to compare that to alpha, the significance level. So let's go back to our notes and I'll show you how this works. So here, if you look at this, the calculator have all the details. So please go over that, whatever I just explained. Now we got P, which is P value is 4.25 times 10 to the power of negative 7. This is much less than alpha, which was 0.01. Be careful, this alpha is not the proportion, is the significance level in the problem. So if P value is less than alpha, then we know what is P value. P value is this red area, or the one that I'm shading now, after the test statistics, which was 4.93, and that's much smaller than this whole area. If p-value is smaller than alpha, then you say reject HO. This is the second way of making the conclusion. So one way, if you know one way, it's good enough, but you can present one way, but know both ways. So, and it's less time because again, this is in the shaded area, the test statistics. Here is the solution provided to you. One thing I want you to notice with those solutions, they do the conclusion in a little bit different, but it says the same thing. Here it says there is sufficient evidence to warrant the rejection of the claim that no more than 1% are defective. The warrant of we have evidence to warrant the rejection. But the way I do it, I say we have enough evidence to we don't have enough evidence to support it. So they exactly mean the same thing. So the one on the test, the solution of the test is that we have we warrant the rejection. The way I say it, I say not enough evidence to support it. So please read both conclusions carefully and you'll see they are exactly, they mean the same thing. Number 8, according to a recent poll, 53% of Americans would vote for the incumbent president. If a random sample of 100 people result in 45% who would vote for the incumbent, test the claim that the actual percentage is 53%. Use zero point 0.1 significance level. Very important. Is, that means equals. So you write the claim. P is 0.53. That has the equal sign, so we know it's HO. Then H1 is going to be the complement of that, which is not equal to 0.53. We wrote that claim first, and that claim is in the problem, so that's our original claim. And of course, H1 is the counterclaim. We check that sign is not equal to, so we're dealing with a two-tailed test here. So to find the critical values, it's a two-tailed test. So you have to divide alpha by 2. So 0.1 divided by 2 is going to give you 0.05. Use inverse norm 0.0501 and you get, this is one of the common one, like 90% confidence level, so it's negative 1.645. This is negative 1.645, and of course the one on the right will be positive 1.645. Test statistics, the claim is about population proportion, so same formula, p hat minus p over square root of p times q over n. The sample proportion is 0.45, it's given in the problem, minus the one in the claim is 0.53 divided by square root of 0.53 times 1 minus 0.53, and n was, sample size was 100. If you do that, you get negative 1.603. Negative 1.603 is before negative 1.645 if we go to left. So basically is in the non-shaded area. If test statistics falls in the non-shaded area, the first conclusion is fail to reject HO. If I fail to reject HO, that means I accept HO and I reject H1. Then take a look at the original claim. The original claim, next to original claim, it says accept. When you accept the original claim, that means you have enough evidence to support the original claim, or the claim is in the problem. So I wrote it here. I wrote it here for you, enough evidence to support the original claim. Calculators, same way. You go to stat, test, and you pick one prop. Z-test, it's exactly like the previous problem I did, so I'm not going to project that one. And here also, X was not given. You're going to need that for your calculator, so just to n times p hat. And then you see X, just enter 45. And if you do that with your calculator, you get 0.018. Again, p-value is p in the calculator, and it's the area right here. And that area is 0.108, which is greater than zero point 0.1 alpha. So since it's two tel, you're going to do that tel plus that tel. Since p-value is greater than zero point 0.1 or alpha, again, you can say fail to reject HO. And at the end of each problem, I brought the solution down to, so you can take a look at the solution at the end of the test. I wrote it for you. So one more time, when you read this conclusion, it's exactly the same way I do, but it's worded differently. Here it says there is no sufficient evidence to warrant the rejection. And the way I say it is say there is sufficient evidence to support that. So warrant to rejection, that means supporting it. Number 9, various temperature measurements are recorded at different times for a particular city. The mean is 20 degrees Celsius, obtained from 60 temperatures on 60 different days, assuming that sigma, very important, sigma is 1.5, test the claim that the population mean is 22 degrees Celsius. Use 0.05 significant level, that means alpha equals to 0.05. So I put the givens, x bar is given, and we have it. We have sigma. Just remember, when the claim is about the mean, if sigma is known, then you use z. Always, don't think, in this case, don't think about the sample size. Whenever you see sigma, then use z. The one in the claim, what's the claim? Test the claim that the population is 22, so 22 is in the claim. So we write the claim first. Mu is mu is 22. Equal sign, that means that's HO. So H1 right away, we know it's going to be mu is not equal to 22. That's H1. We wrote that first, so that's in the problem, so that's our original claim. And of course, H1 will be the counterclaim. This is, we check that sign, not equal to, so we're dealing with a two-tail test. You have to divide alpha by 2. 0.05 divided by 2 is 0.025. It's this area. One more time, sigma is given, so we are going to use z. So if you want to find the critical value, you use inverse norm. 0.0501, you get negative 1.96. Write it here, and of course it's symmetric, and the positive one is going to be positive 1.96. Next is the test statistics. This is a z-test again. So the test statistics, you will have the formulas, but you don't have to memorize them. It's x bar minus mu, that's in the claim, divided by sigma, which is 1.5, is given over square root of n, which is square root of 60. If you do that, you get negative 10.33. Where is negative 10.33? Is right here, right? Much smaller than negative 1.96. And it's in the shaded area. Shaded area, that means reject HO. So you come to HO, and next to it write reject. So of course we're going to accept this one. Then check OC. Next to OC it says reject. If I'm rejecting OC or the original claim, that means I don't have enough evidence to support it. So last conclusion, you say not enough evidence to support the original claim or the claim that says mu is 22. Now, if you want to do this with your calculator, let me share the screen with you. So same thing, you go to stats, you go to tests, And this is just number one, z-test, because sigma was known. So enter that. The input, it's not data, it's stats, because everything is given to you. The sample statistics is given to you. So mu 0 is the mean in the claim, and we had 22. And if you were on sigma was given, which was 1.5. So you can do, oh, I made a mistake, it's stats. One more time, guys. You are given the mu and the x bar, so just go directly to stats. So that's 22, that's 1.5, and the sample mean was 20. And our sample size here was 60. So you go down, you look at your H1, it was not equal to, so the first one is the right one. And you calculate. So negative 10.3, we found out ourselves, that's the claim, the H1, and the p-value is 5.3 times 10 to the power of negative 5, very, very small, now so much smaller than alpha, so that's why we said we reject HO. Let me share the other screen now. So I didn't write the p-value here because not needed, but then when you do your calculator, the calculator gives you p-value. P-value, if you want to know, it's this little area. So after, to the left of the test statistics, and it's inside alpha, so it's smaller than alpha. So number 10, a random sample of 100 pumpkins is obtained and the mean circumference is found to be 40.5 centimeters. Assuming that the population standard deviation is known to be 1.6 centimeters, use a 0.05 significance level to test that the mean circumference of all pumpkins is equal to 39.9. One more time, the keyword assuming that the population standard deviation is known. So when you hear that, that means sigma is known, that means we're going to use a z-test. So I put the givens here for you. So what's the claim? The mean circumference is equal to. So you write that first. We have the equal sign, so that's HO. H1 will be the complement, which is not equal to 39. And we wrote that first, so that's OC, or the claim in the problem. And of course, H1 will be CC. Same thing, this is a two-tailed test. So in order to find the critical value, you have to divide alpha by 2, and you get 0.025. You go your calculator again, this is distribution, inverse norm 0.02501, you get negative 1.96. So this will be positive 1.96. Test statistics, same formula we used for the previous problem, and calculator gives you that. Also, you don't have to memorize because you can have the list of these formulas. X bar was 40.5. The one in the claim is 39.9. Mu sigma was known to be 1.6 and then is 100. If you calculate that, you get 3.75. Where is 3.75? It's right here. So it's in the shaded area. Right away, when I see it's in the shaded area, the first thing I write is reject HO, and go to the claims, and next to HO put reject. And of course, we're gonna accept the other one. So then check where is original claim. Next to original claim, it says reject. If it says reject next to original claim, that means we don't have enough evidence to support the original claim. Not enough evidence to support the original claim, and I put this is the conclusion. That's the solution of the uh, test resource. So it's right here. It's very similar. Calculator, same way. Stat test. This is the z-test number one. And then you pick stats, not data. And mu0 is 39. Basically, you put all these givens. And if you, the p-value, you're going to see 1.76 times 10 to the power of -4, which is very close to 0.002. So that's even more exact. And it's much less than alpha because it's this area. And I wrote it for you. Since it's smaller than alpha, you say reject HO. One more time. Conclusions, you have the traditional method, which you only look at Z, and that should be good enough. But also you have the p-value method, where you compare the p-value to alpha. So both ways are fine. Whichever way you're comfortable, no both ways, but just use one way during the test. Number 11, use a significance level alpha 0.0 equals to 0.05 to test the claim mean equals to mu equals to 32.6. The sample data consists of 15 scores where X bar is 39 and S is 7.8. Be very careful here. We are seeing S. If you are seeing S, that means automatically this will be a t-test. So I put the givens for you. The claim is already given here. So you write that, and we know that's the original claim. We know we have an equal sign, so that's HO. H1 is going to be the complete opposite or complement not equal to, and that's going to be the counterclaim. Again, two-tail test. So you divide alpha by 2 is 0.05. You get 0.025. And here you have to be very careful. This is a t-test because S is given. I wrote it for you. So the critical value is not inverse norm anywhere. Don't make the mistake. It's inverse t. 0.05 and 14 are the degrees of freedom because n is 15 and degrees of freedom are, the formula is n minus 1. So now when you find the critical value, you get negative 2.14. Write it here, symmetric again. 2.14 is on the right side too. Test statistics is very similar to the Z, but instead of S sigma, we put S here. And it's T, don't forget. 39 is in the sample, 32.6 is in the claim over. S was given the sample standard deviation and over square root of 13. If you do that, you get 3.18. Where is the 3.18? It's after 2.14 and it's in the shaded area. So first, reject HO. If I reject HO, I write reject next to HO and accept H1. And I check for OC. Next to OC, it says reject. If I'm rejecting the original claim, that means I don't have enough evidence to support it. So not enough evidence to support the original claim. And please check that, that's the answer. Same thing here if you read it carefully. So I won't go over this now because I already told you how it works. Calculator, you go to stat test, and this time is t-test. And I can share that to show you. So let's see. Stat, test, t-test. And again, you pick stat because you are given the data. So let me enter that. And here the claim, mu in the claim was 32.6. X bar was given to be 39. S sub x is the sample standard deviation. That was S, which is 7.8. And check H1, it says not equal to. Let's calculate and compare the answers. So 3.29, and when we did the calculations, we got a 3.18. Maybe I put something wrong. Let me double check. So the one in the claim was 32.6. That was correct. X bar was 39. That was correct. And N was 15, not 60. So let's put 15. So be careful. And if you do that, yeah, 3.18, we got it. And the p-value is 0.0067. So we got the same numbers in our calculation. So 0.0067, again, is much smaller than 0.05. So that's why you say reject HO. All right, let's go over the next problem now. Number 12, a test for sobriety involves measuring the subject's motor skills. 20 randomly selected sober subjects take the test and produce a mean score of 41 with a standard deviation of 3.7. At 0.01 level of significance, test the claim that the true mean score for all sober subjects is equal to 35. Use the traditional method. Traditional method, that means you don't need the p-value here. So you just compare the test statistics to the critical value. So now, one thing to be very careful here. 22 randomly selected sober subject produce a mean of 41 and standard deviation of 2.7. This standard deviation belongs to this 20, 22 or 20, sorry, randomly selected people. So it's a sample standard deviation. That means it's S. So when you see S, it doesn't say population standard deviation or true standard deviation. This is only for the sample. So if it's S and I put the row, this is the sample standard deviation of n equals to 20. So right away, we know it's going to be a t-test. So let's see what it says. We have to test that the mean equals to 35. So you write that mean equals to 35. That's equal sign, so that's HO, and H1, the mean is not equal to 35. So here, the original claim, we wrote that first, so that's OC, and the counterclaim is CC. So now the critical, this is a two-tailed test. So we take 0.01, we divide by 2 is 0.05. So we're going to use inverse T one more time. So it's 0.05 degrees of freedom or 19. So if we do that, we get negative 2.81. And of course, this one is going to be positive 2.81. Test statistics, x minus mu over s over square root of n. So it's 41 minus 35. 3.7 was for the sample, and over square root of 20, you get 7.25. 7.25 is right here, is in the shaded area. So the first thing you say, reject HO. So you come to next to HO, you put reject. Of course, we're going to accept this one. OC, next to OC, it says reject. If I'm rejecting OC, that means we don't have enough evidence to support the original claim. So you write not enough evidence to support the original claim. If you want to use your calculator, it's exactly the same way as the previous problem. You go to t-test, pick statistics or stats, input the numbers, and calculator is going to give you that and the p-value, but here we don't need the p-value. Number 13, a test of a computer component is found that the mean time between failures is 520 hours. Modifications is made which is supposed to increase the time between failures. Test on a random sample of 10 modified components resulted in the following times. So the times are given here. So the data is given to you in this case. At 0.05 significance level, test the claim that the modified components, for the modified components, the mean time, so this cut off, that should be E, the mean time between failures is greater than 520. Be very careful, greater than. Use p-value method for testing the hypothesis. You don't have to use p-value on the test, use whichever one you're comfortable with. So the givens are n is 10, 520. We have to calculate x bar and s. So the fastest way you can calculate that, put the numbers in L1 and go to 1 bar stats. Just like in the beginning of the semester, you get x bar is 537.1 and s sub x, which is the same thing as s, is 20.7. Degrees of freedom is 10 minus 1, which is 9. The claim set greater than, so you write this first, greater than 520, so you know right away there's no equal sign, it's H1. So HO mu equals to 520. So we wrote that claim first and it's in the problem. Therefore, that's the original claim. And of course, HO in this case is going to be the counterclaim. Greater than 520. So it's a right tail test, and this is a t-test. So you go inverse t.05, do not divide that by 2 because it's just one tail. Degrees of freedom are 9. If you do that, you get negative 1.833, but you take the positive one because it's a right tail test. Test statistics x minus mu over s over square root of n, and we have all this. This is in the claim, substitute. You get 2.61. Compare it to 1.833. It's in the shaded area. Right away, shaded area, you write reject HO. If I reject HO, you put reject next to HO. So I'm accepting H1. Then go to OC. Next to OC, it says accept. If I'm accepting the original claim, that means I have enough evidence to support it. So you write enough evidence to support the original claim. Calculator, you can go 2 ways to do the calculator. And I think, let me show both ways. So go to stat, calc, and that's a t-test. If you pick stats, it's completely okay because you already calculated x bar and s, so you can put those values. So x bar is 537. Point 1, and you go down. Oh, that's in the claim. No, the top one is in the claim. In the claim was 520. So you go down x bar, we found that to be 537.1. And the standard deviation, we found that to be 20.7, and n was 10 because we had 10 items. And it's greater than. So you pick the third one, enter that, and calculate. So, and let me 2.61, and you have the p-value is 0.01, and 0.01 is much smaller than 0.05. So that's why we reject HO. Now let me go to stats. What you can do, you can put all these data in, they're not the same, but the given data, you can put all the data in L1. I'm not going to do that because it's going to take time. But if you put all the data in L1, then when you go to stat, test, and t-test, you can just pick data. And if I enter that, just put L1 here and it's already there, then the calculator is going to give you the test statistics and the p-value. So that's the second way of doing it with your calculator, because here we have the data. So try to do that and you'll get the same answer. And I wrote it here for you. So the notes. Number 14, when 12 bolts are tested for hardness, their index have a standard deviation of 41.7. Test the claim that the standard deviation of hardness indexes for all such bolt is greater than 30. Use 0.025 level of significance. This is a claim about standard deviation. So I put the givens here. Of course, we need the degrees of freedom. Write the claim. The claim says sigma, be careful, is greater than 30. Greater than no equal sign, so that's H1. HO, you write sigma equals to 30. We wrote that first and it's in the problem, so that's the original claim. So the other one is the counterclaim. This is a right-tail test. However, it's not symmetric because it's a chi-square test. So to find the critical value, we need this area, 0.025. 0.025, so no calculator for this, so I brought the table. 0.025 degrees of freedom are 11, so the number is 21.90. So that's the test statistics. No, that's the critical value. Test statistics chi-squared is n minus 1 s squared over sigma squared. Again, you have these formulas. Substitute and you get 21.253. 21.253 is before 21.9. So the first thing we say is fail to reject HO because we are in non-shaded area. Fail to reject HO, that means accept HO and reject H1. Then you check OC. Next to OC it says reject. If I'm rejecting the original claim, that means I don't have evidence to support the original claim. So the final enough evidence. Oh, so this one should be not enough evidence. Let me fix it. Not enough evidence to support the original claim one more time because we rejected the original claim. So, and you have the solution right there. So you can check that too. Number 15, and that's the last one. The standard deviation of math test scores at one high school is 16.1. A teacher claims that the standard deviation of the girls' test scores is smaller than 16.1. A random sample of 22 girls results in a score with standard deviation of 13.2. Use 0.01 significance level less than 16.1. I wrote the givens for you. The claim says sigma is less than 16.1, so that's H1 because no equal sign. HO again, right, sigma equals to 16.1. And let's go do the testing. This is a left tail test. Be very careful. If it's left tail and I want to read the critical value, I have to know this area. So in this case, you have to do 1 minus 0.01, which is 0.99. If you go to the table, 0.99, degrees of freedom are 21, so you get 8.897. So this is our critical value right here. Test statistics, again, you use the formula. You don't need to memorize this. It's going to be given to you. It's already there. 22 minus 1 times 13.2, the sample standard deviation score divided by the one that's in the claim. And you get 14.116. Compare it to the critical number. It's much greater than that. So it's in the non-shaded area. So fail to reject HO. Fail to reject HO, that means we accept HO and reject H1. Next step, look at OC. Next to OC, it says reject. If I'm rejecting OC, that means I don't have enough evidence to support the original claim. So, and you got the solution. Okay, that's it. It's a good idea to watch this recording 2, 3, or even 4 times and get you ready for the exam. Once you watch it, then don't look at it at the solution and try to do it yourself. Hope you all have a good day and I'll see you soon. Bye bye.